Alex's roller coaster, how to create a polynomial function given roots plus 1 point. A couple weeks ago, one of my valued YouTube subscribers, Alex, came to me with this problem. Little did he know that A, we were doing something very similar in my Algebra 2 classes at the same time, and B, that this is one of my favorite types of problems. Using lengths of pipe insulation and an XY coordinate grid, Alex made a roller coaster. He found that he could get the marble to pass through the roller coaster when it went through these 4 fixed points. Here going down through the x-axis at x equals -30, coming up through the x-axis here at x equals -2, continuing upward through a y-intercept of 1, and then turning down again and going through x equals 20. The next thing Alex did was to formulate each binomial from its root. X equals -30 becomes x plus 30 equals 0. To get this, we need to have 0 on one side of the equation, so x plus 30 equals 0. For a root of -2, that translates into a binomial factor of x plus 2 equals 0. And finally, the root of 20 translates into the binomial x minus 20 equals 0. Alex has done some very sound algebra thus far, so he went on. He concluded that f of 0 equals 1 times the quantity x plus 2 times quantity x plus 30 times quantity x minus 20. Then from there he multiplied it all out and got x to the third power plus 12x squared minus 580x minus 1200. How did he get this? He first multiplied quantity x plus 2 by quantity x plus 30 and got x squared plus 32x plus 60. Then he took this x squared plus 32x plus 60 and multiplied it by quantity x minus 20 to get x cubed plus 12x squared minus 580x minus 1200. Then he was mystified by having to reconcile the apparent calculated y-intercept of -1200 with the actual experimental y-intercept of 1 and questioned what he had to do to get a function that would still pass through all the x-intercepts and have a y-intercept of 1 that would describe the path of his roller coaster. If we were to put this function into our graphing calculator like this, and after adjusting the window to be able to see everything, this is what it looks like. It goes through -30, -2, and +20, just like Alex's roller coaster, but it starts by going up instead of going down, and it goes up to almost 8,000 units in height. In fact, the relative maximum is -18.5, 7,310. And then it goes down through -2 and on the x-axis and through the y-intercept of -1200. All the way to the relative minimum of the coordinate 10.5, -4,810. And then up through the x-axis at x equals 20. In this version of the roller coaster, the x-intercepts are all correct, but the function goes up when it should go down, and its amplitude is all crazy with the y-intercept of -1200 and the maximum and minimum in the thousands. Where did Alex go wrong? This is what Alex started with a few slides back when he put the binomial factors together. F of 0 equals 1 times quantity x plus 2 times the quantity x plus 30 times quantity x minus 20. Instead, the form of the equation should have been f of x equals a times the quantity x plus 2 times quantity x plus 30 times quantity x minus 20. Next, we take the coordinates from the one other point, the only point that is not on the x-axis that we have, and that is the y-intercept of 0, 1. The y-coordinate of 1 replaces the f of x on the left side of the equation, and the 0 for x replaces x in these 3 places in the equation. So the equation looks like this, with the 0 replacing the x's. So this simplifies to 1 equals -1200a. So solving for a, we have a equals -1 over or divided by 1200, which decimalized approximates to a equals -0.000833 and so on. So now we can put a back into our equation as a number, and we have f of x equals negative 0.000833 times quantity x plus 2 times quantity x plus 30 times quantity x minus 20. And here is the equation placed into the function line of the calculator. We press enter to graph, and this is what we get: the amplitude of the graph so flattened with the current window that we cannot even see it. I'm now adjusting the window settings as shown here, and all I changed was the y minimum to negative 10 and the y maximum to positive 10. And this is what it looks like, graphed. Now I'm moving the graph to the bottom right to show how this meets the basic parameters of Alex's original experimentally determined roller coaster. And we see that it has all the intercepts, x and y, in the same places. Now we'll multiply all these three factors, quantity x plus 2 and quantity x plus 30 and quantity x minus 20, together like Alex did earlier. And that gives us negative 0.000833 times quantity x cubed plus 12x squared minus 580x minus 1,200. We could distribute the value of a, negative 0.000833, to all the terms inside parentheses, but that will not really help us understand the situation any better, except in multiplying negative 0.000833 times the last term inside, which is negative 1,200, which will give us our y-intercept, which shows here at 0.9996. That's very close to 1, and would be 1, except the negative 0.000833 is itself a rounded off number and not exact. And after offering my suggestions, what was the response from Alex? What I thought was a heartfelt thanks, as shown in the actual YouTube message caption on top. He noted that it was really simple, but that he had a type of writer's block, but for mathematics. We can learn something from Alex here. If sometimes we're stuck on a problem, it can help to have someone take a fresh look at it for us. Often it will be something pretty easy that we're just having trouble seeing at that time. I would like to thank Alex for bringing this fine problem to my attention. I had done this before with quadratic functions, but not until now with a cubic function. This has been Alex's Roller Coaster, how to create a polynomial function given roots plus 1 point. Thanks for viewing.